Hey guys, welcome back. Last two examples for today. We're going to be finding the areas of sectors and segments in a circle. All right, it says a sector of a circle is the region bounded by two radii. So here's our two radii, NQ, MQ, and the intercepted arc, which is arc MN. So that region we see there shaded in green is what we call a sector. And we can find the area of this. Notice how it's kind of a triangle, but like kind of not, because it has the arc right here. So we can't just use base times height divided by 2. We have to use a formula. And this formula comes from the area of a circle, very similar to arc length, where we use circumference. For area, we use the area of a circle, and we times it by just the portion we are focused on, just the arc, the intercepted arc that we are looking at. All right, let's go ahead and first start by finding the area of the sector. And to do that, here's the formula we're going to use every time. I have to find two things, N and R. So the radius, they should always give to us, and it looks like that is 10 centimeters. So I'm going to start by plugging that in first for R. And now let's find N. N, same thing in the arc length formula, it's the arc measure, or that's the same thing as our central angle. Here's the arc that we're focused on. We call that the intercepted arc, and we can see that the arc measure is 78 degrees. That means that our central angle has to be 78 degrees as well. In every question, they're going to give it to you a little bit different, but we just want to make sure we're seeing that a central angle, as long as it's an angle that starts at the center, that will always be the same as its arc measure that it opens up to. And that's always going to be our N value. Let's go ahead and plug that in for N. 360 is always on bottom. All right, let's simplify. Just like we did with arc length, we're going to start by simplifying the numbers we have next to pi. So we're going to keep pi how it is, though. We want to have pi in our answers, and 10 squared is 100. So that is the same thing as 100 pi. All right, last step. We're just going to times our numbers on top. So 100 pi over 1, and we're going to times that by 78 over 360. Again, we want to leave pi in our answer, so we're really just timesing those two numbers that I highlighted. And we are getting 7,800. Pi is on top, and on bottom 360. And for simplifying, we're just going to do this. Take out as many zeros on top and bottom as we can, as long as we're doing it evenly. So we can only take off 1 0 on top and bottom, and that leaves me with 780 pi over 36. That is the area of our sector. All right, we're going to take it up one small notch, and that is now to find a segment. So if we look at this next example, I'm going to draw in blue the sector. So that would be the sector, and we have to use that information to find the area of our segment. The segment is what you see highlighted in green. So that is just this little portion right here. How we're going to find that little portion is we're going to find first the area of the sector, now that we know how, and then we're going to find the area of this triangle that is formed. And we're going to subtract that triangle area away from the sector, and what's left over will be this green section. All right, let's do it. We're going to start with finding the area of our sector. Here's our formula. Let's go ahead and find our radius, find our arc measure. The radius looks like is 10 again. So we're plugging in 10 for R. And the N value is our arc measure. So our intercepted arc is this guy right here. I don't see the arc measure. The angle measure they would show us, if there was an arc measure, they'd put it right here in degrees, and it's not there. And we also don't really have a central angle that we can see, but we do have a right angle. And what does a right angle measure? 90 degrees. We have a right triangle. So my central angle is 90 degrees. That means my arc measure is also 90 degrees. There's our N value. Let's go ahead and plug that into our sector formula. All right, we're going to simplify this through. Now, right here, again, we just have 100 pi. And I'm going to times the numbers on top, times the numbers on bottom. On bottom, we're still just going to have 360. That's going to be pretty consistent throughout all these problems. But on top, this number will change. 100 times 90, we're going to get 9,000. And then, of course, pi is still going to stay on top. The only simplifying we're going to do is getting rid of zeros. Looks like we can take away 1 on top, 1 on bottom. And our final sector area is 900 pi divided by 36. That's the area of the sector. We actually don't want that as our final answer. We want to know the area of the segment. So the segment now, we have to find the area of the triangle and then subtract it away from the area of our sector. All right, let's do it. So now when we find the area of a triangle, we do need to have a right angle because that right angle separates my base and my height. Now, the radius is always consistent. All radii are equal. So if this radii, QM, is 10, so is QN. Those are both 10 feet. So my base and height where the 90-degree angle meet is 10 times 10. And with any triangle, to find its area, we have to divide it by 2. And that means we get 100 over 2, which is 50. So we have the area of our sector. We have the area of our triangle. To find the area of the segment, we're going to subtract those two. So my final answer is 900 pi over 36 minus 50. That right there, we're not even going to simplify. We're just going to leave it exactly how it is. Now, one thing I'm kind of noticing, and this is totally not a requirement. I'm very satisfied with this answer right here. That is 100% correct. But I think I'm noticing that this fraction here, 900 over 36, we might be able to simplify that into a perfect whole number. Let's see, 900 divided by 36. That itself is 25. Just a bonus, if you ever see that and you want to try to simplify it, all it does is make our answer look a little bit nicer, but I'm not going to require it right now. This answer is great. I'm not going to require you to simplify, but if you can, if you want to, you see that it simplifies to a whole number or some other nice fraction, you're welcome to simplify it as far down as you would like. Both answers are acceptable right now. All right, we found the area of our segment with a right triangle. Now, what do we do if we have a different type of triangle? Let's take a look at one more example today. So here's our circle, and we want to find the area of the segment, this green shaded portion here. Step 1, we got to find the area of the sector, this guy right here. Then we find the area of the triangle, and then we subtract the two. Let's start with our area of our sector. Here's our formula. The two things we need is radius and the arc measure or central angle. Our radius is 8. The central angle, our central angle is 60 degrees. That is also our arc measure. Just bonus, we can write that out here. That's the measure of xy, arc xy. And that's always our end value. All right, I'm going to simplify and get a final answer for the sector area. Here's what we get. All right, just going to times the numbers on top now, 64 and 60. All right, and on top, I'm getting 3,840 pi over 360, of course. Let's cross out 1 0 on top, 1 0 on bottom. The final area of our sector is that number right there. All right, we're going to circle that. We'll come back to that in a little bit. We got to find the area of our sector, and now we have to find the area of our triangle. Now this triangle, if I want to find the area of that, I can't really see where my base and height are because remember, our base and height always meet at a 90-degree angle. It's easier with a right triangle. If I don't have a right triangle, then I'm going to have to solve for my height. Essentially what I have to find, I have to draw in my own altitude and draw in a line that forms a 90-degree angle so that we can find the area of that triangle. All right, we're going to break this down. So this triangle here that I drew in red, I want you to imagine what that looks like. Here's what that triangle is. So all around we have 8 degrees, what units are we in? Centimeters. That's our radii. So we have 8 all around. This is an equilateral triangle, and every angle measures 60 degrees as well. If I'm going to construct my own height, I have to draw in this right angle here. Then that's going to split up this side over here, right down the middle. It's going to split the angle 30-30. It's an angle bisector. And it's also a perpendicular bisector. It splits that side into 4 and 4. So really what that helps me find is now we can just focus on one of those right triangles. We have a 60-degree angle, a 30-degree angle, and our radii, of course, and just one side is 4. This length, the purple line that I drew down our triangle, is our height that we need to find in order to find the area. So here's our question mark. How are we going to find that? Well, in any right triangle, we can use Pythagorean theorem. So we're going to do a squared plus b squared, that's our question mark, equals 8 squared. All right, go ahead and simplify that down, and we're looking for our height. All right, I'm going to call our height h for now. And what I am getting is that h squared equals 48. Let me double check that really quick. Yep, 64 minus 16. All right, yep. Now, when I take the square root, we want to solve for h exactly. We're left with the square root of 48. Let's just leave it like that for now, guys. We absolutely could simplify that. We could break it down into perfect squares, but for now, we'll just leave it like that. The height is the square root of 48. Approximately, let's just see if that answer makes sense. That's about like 6.9. That sounds about right. It doesn't want to be, it can't be longer than the hypotenuse. Should be a bit longer than our other leg. So square root of 48, we're going to lock in with that as our height. Now we're ready to find the area of our triangle. We now have our base. We also have our height, square root of 48, and we can go ahead and punch that right into our formula. All right, so the base where our 90-degree angle meets was 4. Our height we found was the square root of 48, and then we divide all that by 2. All right, let's go ahead, simplify that in our calculators. And when we do, here's what we're left with. I didn't really do too much simplifying in my calculator. We can just leave it like that. Let's simplify the 4 and the 2. If that was a fraction on its own, we can divide them each by 2. And we are left with 2 square root of 48. All right, that was a lot of work to find the area of the triangle. I will say, guys, that won't happen in every question, but now we know how to handle it. Last step, we're still looking for what's the area of the segment. Well, we have the area of the sector. We have the area of our triangle. Last thing we have to do is put a minus sign in between them, and that is our final answer. All right, this one is going to be a lot, so I'm going to scroll down here a little bit. Here's our final area of our segment. 384 pi over 36. The sector minus the triangle.